Hi, good day everyone. My name is Trishel Gokool and I will be presenting a survey of current trends in manufacturing engineering postgraduate programs in the United Kingdom on behalf of my co-author and me. In countries around the world, manufacturing has proved to be an effective growth strategy. However, the amount of growth derived critically depends on the skills and education of the human capital. Without the right skills, a nation cannot extract all the benefits that this growth has to offer. To top it off, manufacturing engineering education faces many issues with the incorporation of industry needs and new advancements into its curricula, mostly because of the fact that manufacturing is a rapidly changing field and finding the right balance between future and current but soon to be obsolete topics within a short time frame is a significant challenge. Moreover, altering outdated topics or adding new courses to a program is challenging as most curriculum committees lack data for guidance on decisions and validations. The present study investigates the curricula of postgrad manufacturing engineering programs in the UK with the intention of using the findings as a benchmark for future research that will be discussed in my other presentation. So, some may ask, why the UK? Well, it was selected because of the similarities between our education systems and because it is a developed country that has made significant contributions to manufacturing, such as being a center of the first industrial revolution and one of the epicenters of the fourth industrial revolution. For this study, a survey was performed on the current postgraduate curriculum of UK universities to determine general trends in curricular content, identify the topics that are covered in various curricula, and briefly discuss collaborative research efforts. Methodology. Data on accredited MSc programs in manufacturing engineering was collected from the Engineering Council's accredited course search database using the search criteria outlined in this slide. After compiling a list of programs, the latest program descriptions were downloaded from the respective university's website. Categories were then defined to map the courses, as similar courses may have different names. Next, a simple frequency analysis was performed to determine the trends, and finally, the research activities of a few universities were investigated to gain insights into the research aspects of postgraduate research. The table on this slide gives a snapshot of some of the course categories used to map the courses. For example, computational modeling included computer-aided engineering, finite element analysis, computational engineering modeling, and computational fluid dynamics. Now, moving to the findings. For the curricular structures, it was found that 25% of universities offer multiple manufacturing engineering graduate programs. 80% of programs span 1 year full-time. 47% consist of 8 courses. Some programs span up to 18 months full-time and can comprise of as little as 4 or as much as 9 courses. More than half of universities have no elective courses, requiring the students to undertake all courses. MfgE is the most popular accreditation standard for UK universities, and all programs require students to complete an individual project. The main comment by the reviewers was that the paper should have included a comparison with UWI's own MSc Manufacturing Engineering and Management. We didn't include it in the paper not to disturb the flow, but I've added it in here. So, for a quick comparison, we have one manufacturing engineering program at UWI that spans 18 months full-time. It has more than the UK average of courses with 10 and has 4 electives, so students can somewhat tailor their studies. It is accredited by MfgE and does show up on the ACAD database of accredited programs and does involve an individual project. The main course themes are shown here. The ones in green, such as research skills, management, advanced materials, manufacturing systems, etc., were the most popular course categories. And, as you can see, they are a mixture of soft skills and core manufacturing topics. The ones in red are the least popular, such as advanced machining, metrology, and Industry 4.0. which is a bit surprising, but topics like Industry 4.0 are sure to become more popular in the near future. This graph shows the compulsory versus elective courses in each category, because although courses may be popular, they may be offered only as elective courses which students may not take. Courses such as manufacturing systems, advanced machining, and research skills are only offered as compulsory, while precision engineering is only offered as an elective. Summarizing those findings, the most significant course categories are computational modeling, design, system simulation, manufacturing systems, robotics, advanced machining, management, and research skills. Comparing again to UWI's MEM program, we see all but one category offered, with 4 being core modules and 3 being electives. I'll now quickly go through the research and collaboration efforts. Funding is provided by the UK government, European Union, industries, and UK charities. State-of-the-art laboratories perform cutting-edge research in areas such as advanced materials, manufacturing sustainability, CAD, 3D printing, etc. The curricula of taught graduate programs are thus guided by leading research, so the curricula is kept current and industry relevant. Universities in Trinidad and Tobago would do well to adopt a similar approach to curriculum refinement. Currently, government and industry have done poorly to establish mutually beneficial collaborative research with universities. Going into specific universities, University of Manchester. University of Manchester houses 3 business innovation centres which undertake approximately £420 million worth of leading research. Also, they are trying to become the hub of Industry 4.0 in the UK. Loughborough University. Loughborough University hosts 2 of the UK's national EPSRC centres for innovative manufacturing and are partners in 3 more. Industry collaborations ensure that the university works on live projects. And one that wasn't included in the previous analysis but still contributes greatly to manufacturing, University of Cambridge. The University of Cambridge has an Institute of Manufacturing which embarks on research and consultancy. They also offer a 1-year MPhil in industrial systems, manufacture, and management. In conclusion, a brief survey was undertaken on UK graduate manufacturing programs using the ACAD database as a starting point. It was found that both soft skill courses and core manufacturing topics were dominant, as manufacturing engineers should utilize both. Also, emerging fields like Industry 4.0 are taught only in a few programs. Research at these universities is funded by many organizations and not only generates income, but guides the taught curricula as well. The findings of this study will be used as a benchmarking tool for improving our local curriculum, as will be discussed in my next presentation. Here is the list of references used in this presentation. Thank you for your time. Questions and other feedback can be emailed to me at trishelgokool@yahoo.com. I'll try and respond as quickly as I can.